Hello and welcome to another video lesson with Mr. Roman. Today we're going to be looking at multiplying polynomials. And on your notes, the first box to fill out would be when multiplying with polynomials, we are simply applying the distributive property. So the distributive property is where you multiply the term that's outside the parentheses to whatever's inside the parentheses. So let's look at an example here, example 1 on your notes, where you have a binomial inside the parentheses and we're multiplying by y. So we're going to use the distributive property here, and we're going to multiply the green y to the red 3y and then to the blue 2. So first, y times 3y, and then y times 2. And then when I multiply the y times the 3y, remember I get 3y squared. And when I multiply the y times 2, I get 2y. So then our simplified expression would be what I've circled in purple here. Example 2, you have a trinomial being inside the parentheses, being multiplied by the term 3x squared. So again, we're going to use the distributive property, multiplying the green to all the red, blue, and purple inside. So 3x squared times x squared, then 3x squared times 2x, and then 3x squared times negative 4. So the first term, when I take 3x squared times x squared, that's going to be 3x to the 4th power. And then when I take 3x squared times 2x, I'm going to get 6x cubed. And then when I take the 3x squared times the negative 4, I'm going to get negative 12x squared. And then in this case, that would be our simplified expression. And also notice that this is in standard form of a polynomial, meaning that the terms are in descending order of the highest exponents, so to the 4th power, to the 3rd power, to the 2nd power. Example 3, here we have another trinomial inside the parentheses, and then this monomial here. So let's see what the distributive property looks like. So the green term is going to be multiplied to the red, blue, and purple. So 4x squared y cubed times 5x y squared. And then we're going to take that green times the blue next. 4x squared y cubed times 6x cubed y. And then the third term. Now, when I multiply these two together, I'm going to get 20x cubed y to the 5th. Okay? And then when I multiply these two together, I'm going to get 24x to the 5th, y to the 4th. And then when I multiply these two together, I'm going to get negative 8x cubed, y to the 4th. And then we rearrange this. If you notice, we rearrange the terms so that the highest exponent here, which is x to the 5th, we're going to put that as the first term. All right, example 4. We have a trinomial again here times a monomial of 5x, and we're going to take the green times the red, blue, and purple. So 5x times 3x squared, 5x times negative 5x, and 5x times 1. Now, when I multiply 5x times 3x squared, I get 15x cubed. And when I multiply 5x times negative 5x, I get negative 25x squared. And then 5x times 1, anything times 1 is itself, so we're just going to say that's 5x. And then this would be our simplified expression. Example 5, here we have a trinomial inside the parentheses times this monomial of negative 2x cubed, but then we're subtracting 2x cubed. So before I can combine any like terms, I need to first distribute what's outside the parentheses, because think of it like this. If there's a number or a term outside the parentheses, that's like locking in what's inside these parentheses until we distribute. So let's go ahead and do that. The green times the red, blue, and purple. So negative 2x cubed times 5x squared, negative 2x cubed times negative 3x, and then negative 2x cubed times 2. And then I'm going to just bring down this negative 2x cubed. I'm going to just write it along because it's come along for the ride. Okay, so now when I multiply these two together, I'm going to get negative 10x to the 5th. When I multiply these two together, I'm going to get 6x to the fourth. And then when I multiply these two together here, then I'm going to get negative 4x cubed. And then again, this negative 2x cubed is just going to tag along right here. Now we need to look to combine like terms. So here we can see that there's a negative 4x cubed and a negative 2x cubed. And so when we combine those like terms, we're going to get negative 6x cubed. Now this expression at the bottom here is already in standard form of a polynomial. So this would actually be our final simplified expression. Example 6, you have a binomial here times this monomial of 5x, and then we're subtracting 2x times this binomial here. So we're actually going to use the distributive property twice in this case. So let's look at that. So we're going to take the green times everything inside, which will be the red and the blue in both cases. So green times red, blue, green times red, blue. So let's look at that first. 5x times 3x, then we're going to take 5x times 7, then we're going to have negative 2x plus or times 5x, and then negative 2x times negative 2. Now when I multiply here, I'm going to get 15x squared. When I multiply here, I'm going to get positive 35x. When I multiply here, I'm going to get negative 10x squared. And then when I multiply here, I'm going to get positive 4x. Now again, there are like terms in this expression. So we need to say the 35x and the 4x, those are like terms. And then the 15x squared and the negative 10x squared, those are also like terms. So let's just combine the brown terms for a moment. That would give us positive 5x squared. And then when I combine the orange terms, that's going to give me a positive 39x. So this would be our final simplified expression. Example 7 says, find the missing polynomial that makes the equation true. And then letter A, we've got this blank here being multiplied to this binomial of 3y plus 2. Well, in order to get a 9y and a plus 6 after we distribute, let's just look at trying to make the 3y multiplied to be a 9y. And yes, you guessed it. If you multiply 3y times 3, you'll get 9y. So let's test that for a moment. So 3 times 3y would give me 9y. But we also have to test that with the constant. We need a positive 6 here in our answer. And then we can notice that the positive 3 times the positive 2 would give us the positive 6. So in this expression, we would say 3 in the blank is our answer. Letter B, we have a monomial here of negative 2xy times something in parentheses to equal what we have on the outside here. Now, since we're multiplying this negative 2xy times whatever's in parentheses, to undo this, we could just divide by negative 2xy on every term over here. So let's go ahead and see what that looks like. So I highlighted in red. First, we're going to divide that term by negative 2xy, then the second term, then the third term. And when I divide this first term, I get a positive x squared y. When I divide the second term, I get a negative 2x. And then when I divide this third term, I get a positive 1 because negative 2xy divided by negative 2xy, so anything divided by itself is just 1. And so this expression here is what would have gone inside the parentheses here, so that when you multiply by this, you would get what's in black. So we would circle that as our expression. And then the last example, it says, find the area of a rectangle with a length of 4x cubed minus 2x plus 1, and then a width of negative 5x. So here I'm just writing out the rectangle with the information that we know. And to find the area of a rectangle, you take the length times the width. So we're going to take negative 5x times the width, which is 4x cubed minus 2x plus 1. So now when I go to solve this area or simplify this expression, I'm just going to use the distributive property again. I'm going to say that negative 5x is going to multiply to every term inside the parentheses. So negative 5x times 4x cubed, negative 5x times negative 2x, negative 5x times 1. When I multiply it here, I get negative 20x to the fourth. When I multiply it here, I get positive 10x squared. And when I multiply here, anything times 1 is itself. So that would be negative 5x. So here we would say the area of this rectangle is the expression circled in purple. And this concludes our video lesson.